Welcome, everyone, to another week of Engineering Design Omniverse. Edmar's on his way.
I'm here.
Oh.
All you have to do is say my name and then snap.
That's right. It's kind of like Rumpelstiltskin or something like.
Well, it's new NVIDIA teleportation.
Or no, what's a
technology.
good one? What's that?
It's new NVIDIA teleportation technology, but we're not allowed to talk about it yet.
Is that AI powered?
Yeah, it is. Of course. How you guys doing? You guys have a full crowd here today. So we so you're going on with the GTC session material, right?
Yeah, and good news. We don't have any bugs in our code this week.
Impossible.
Actually, that is impossible. We do have some things we're going to have to work out, so not to worry.
What would Jen be here for then?
That's right. Well, and
don't worry, I'm not needed for this part. So I'm just a spectator that gets to ask a lot of weird questions.
Like, well, how do you print to the screen in Python? Like questions like that.
No, more like how does it work? What's going on? Like, trying to act like the person who doesn't know anything.
Yeah, I was feeling all busy because I'm preparing this GTC hands-on lab. Coming to find out that Jen's doing like 3 of them.
Are you doing 3?
Just nods. She's like, no big deal.
Yeah, no big deal.
Wait, so Jen, which ones are you doing?
The USD one, the XR, building like a native app with XR, and then the industrial digital twin app one.
You're in all the hot ones. That's awesome.
Yeah.
Well,
and,
go ahead.
We also have a special guest today.
I see that.
Ayush Ghosh. Is it Ghosh? Is it Ghosh?
It can be both, but yeah, it's usually Ghosh.
Ghosh. Yeah. Oh man. Oh my gosh, I've been saying Ghosh wrong. Oh, all right, Ayush Ghosh am I saying Ayush right? How about that?
That's absolutely perfect.
Okay.
Thanks.
Ayush Ghosh, I'm so sorry. Yeah. And so for those of you who don't know, which I don't know if you do know, Ayush wrote this really cool thing for Omniverse, and it's called like the Isaac ROS Bridge. Is that what you call it? What's it called?
Yeah, so I'm on the team that develops the Isaac Sim ROS Bridge. And so mainly I kind of lead that, but yeah, we develop the ROS Bridge, and what that lets us do is connect Isaac Sim to the world of ROS, which just means you can use ROS to control, your robots in Isaac Sim, or, gather data, sensor data from Isaac Sim to put into whatever workflow you need. And ROS is very versatile, and it's just very standardized, and it makes it easy to just communicate with Isaac Sim to any of your other workflows or applications.
Cool. And we're going to get into that a lot more today, but first, I think we've got some announcements from Edmar, and I gotta find it, but I've got a link for you that will give you 25% off if you register for GTC. So I know early bird pricing has come and gone, but don't worry, we've got your back.
Yeah, we absolutely do. And so we've got a lot of cool stuff happening for GTC, which is now only weeks away. We would love for everyone out there who's a part of the community to either come live so we can meet you in person, introduce you to some folks on our team, partners that might help your projects. Or if you can't make it, don't worry about it. We're gonna be hosting a lot of stuff virtually. And if you look at the session catalog by going to nvidia.com/GTC, Eric will post his link in the chat in a second. You can look at the sessions, and some of them will say virtual. Those ones are actually broadcast live virtually at the same time. However, all sessions will be available, are being recorded, and will be available after GTC, but only right away for people who are registered, even for the virtual GTC, which is free. So if you can't make it, absolutely register for GTC virtual. It is free. You'll have access to all the sessions right after GTC when they're broadcast, or you can watch them live as they're happening, all the ones that say virtual on them. we actually just posted a bunch of cool stuff. Let me get out of the screen. A bunch of cool stuff on our forums regarding GTC. So we have a couple of great opportunities. One is that we are looking for your beautiful content out there to potentially include in the keynote sizzle reel that Jensen himself is going to show off to kick off GTC. There's a nice form you can fill out with all your information and your video and potentially your still images if that works better for you. We'll post a link in the chat in a second, but you just go to our forums and go to announcements and you'll see everything you see on my screen here. We also, just a side note, we have the documentation live one more day. So if you have any feedback on the documentation, Omniverse would be a big help for us as we build and evolve that. Last day for survey is tomorrow. We also have a nice announcement post there that Amelia posted with all the sessions broken down by topic. So we have different sessions, topics like for creators, for people doing work in synthetic data generation, SDG. I was going to get it one day. I should have said SDG. Everyone at SDG, we have all those sessions. We have digital twin topics. So all those are there on that forum post there. And then just last night I did this. I just kind of put everything together on the NVIDIA Omniverse group on Facebook that we have. We have another one on the LinkedIn. So search for NVIDIA Omniverse group. You'll find it there. And then obviously I put this on Discord. This kind of sums everything up. So we would love to talk to you if you're going to attend GTC on site. So we have a quick survey here so you can let us know you're coming. That way we can meet with you and help you with anything you might need while you're there. We are hosting an OpenUSD day. That's going to be super exciting. A full day revolving around sessions on OpenUSD. We're also planning a special event during that day. More details later on that. We're getting that finalized now. And obviously, the keynote is what kicks everything off on March 18th. There's a link there so you can add it to your own calendar super easily. On the Discord server, we have a GTC channel, so you can chat anything GTC there. And then, we're just super excited. I think it's going to be an amazing event. We hope everyone out there can attend either virtually or come. Even better. That would be awesome. Jen, you'll be there, obviously. Yep. Eric, you'll be there. Ayush, are you going?
Oh, you're muted, Ayush.
Yeah, I will be there. I'll be with Eric hosting the workshop.
Yes,
so if you need one more reason to go, there you go. Ayush will be there.
And so just, we have, I'm going to be in the lab, obviously. Ayush is going to be in the lab, who wrote this Isaac Bridge, or who's on that team. We are going to have Jim from Jetson Hacks in the lab. So if you all are Jetson Hacks fans, come join us, meet him. Anyway, it's going to be so fun. And isn't this like the first major GT, or like the first in-person GTC since COVID, or
5 years?
What's that?
I keep muting myself. 5 years. First in-person in 5 years. Yeah.
First in-person in 5 years. Wow. So we're just, I think there's going to be some serious energy at this one, So
it'll be awesome. Well, all right, I got to go, but you guys have a great rest of the stream. I'll let you guys. I don't want to crowd out your awesome information. So I'll be watching though on my monitor right here. So have fun.
All right, cool. We'll see you.
Bye.
All right. So with that, I'm going to bring up. This is actually, I have a Linux laptop. Please be kind to it. It is running an A3000, which is about like a 3060. And we are maxing this thing out. So every once in a while, it has a little bit of trouble. But just, be nice to my poor little laptop, okay? It's doing its best. And I think it'll do well enough. So let's see here. With that, if you remember right, we've got this scene here with the car that can now simulate. And what we want to do is actually start to drive this car around, both manually so that we can train. I think actually we drove it manually with the Xbox controller in the last session. This week we're going to show you how to drive that with ROS, just to kind of show everyone how ROS works. And then we're going to see if we can get it to drive itself with the model we've trained last week, or model we've trained before. So first, let's talk a little bit about what ROS is. What is What is ROS, Ayush?
Yeah, so to put it in a nutshell, ROS is the Robot Operating System. That's what it stands for. And it's basically just a set of libraries and frameworks that you can put together to communicate with any robot that you want if it's set up to communicate with ROS. The reason this is nice is because once you have a ROS-enabled robot, you can, control it from any other laptop that supports ROS or that has ROS installed, or any other system. It's highly configurable, and that's why it's super nice. So, for example, what it is actually absolutely perfect for is something like digital twins. So, if you want to set up something in a simulation, you set it up with ROS, you use your external controllers or whatever that you need to use to communicate with your robot in simulation. And then if you just switch over to the real robot, in theory, nothing will change on your end. So your controller will continue working with the real robot, and the communications shouldn't be interrupted or anything because it's so modular and it's just very standardized. So that's what the nice thing about ROS is. And hey, Eric, so maybe we can open up the ROS graphs that we have set up inside of Isaac Sim for this particular car that we have here.
So we've got ROS. So ROS sensors, that one is what their subscribers. There are two kinds of node, right? Is that right?
Yeah, so there is what we call publishers and subscribers. So publishers are kind of what they sound like. They publish data that they get from somewhere. So it could be sensor data, it could be state information about your robot. It could be pretty much anything. And so we have publishers set up, and then subscribers are the one that are listening in, and they're subscribing to the data stream that you are publishing to, which is what we call ROS topics. So publishers will publish data to a certain topic. Subscribers will then subscribe to that topic to listen in from the data. Or listen into the data, and then they can do whatever processing they need to do on their end with the data that they're getting from that ROS topic.
And we got some questions. What makes ROS real time?
So there's actually two versions of ROS. There's ROS 1 and there's ROS 2. So ROS 1, when it initially came out, was just groundbreaking in that it was super modular and everything. But the main caveat was that it wasn't real time. And so with ROS 2, it's closer to that. It is actually what we can pretty much call real time, and that's because it's handled by DDS middleware software that is kind of handling all of the communications in a real time manner. So it has like accurate timers and things like that we can use to make sure that it is real time.
And so with ROS 1, I mean, it was really modular, but your messages kind of might be out of sync. Is that essentially? I don't know.
Right. So basically, if a publisher is publishing something, you may or may not get it. Most of the time, you would get it. Or if you did get it, as you said, it might be out of sync. It wasn't super guaranteed in terms of when you're getting something. With ROS 2, especially when you're calling a timer, for example, you know that timer is going to run for that exact amount of time that you have set it to run for. Just because rather than handled by high-level programs, it's actually handled by middleware. So, for example, in this case, we're using DDS called Fast RTPS, which is the default one used in ROS 2, and that's what Isaac Sim is set up to do as well.
Cool. That's good. And then a question is, so ROS Bridge, and what is it? And these graph nodes that we've got, and we're going to show you those. Essentially, ROS Bridge lets us treat an Omniverse simulation as if it is the real world, and treat this robot as if it's the real robot. And so this robot is got a publisher. Let's see here. I'm changing between two computers, so I get a little bit off. So this ROS sensors, that's a publisher that publishes the camera and that sensor data out to whoever wants to subscribe to it. And so then there can be a ROS node out on the network that's listening for that camera information. And then here, ROS Ackerman Drive is a subscriber that's listening for any commands that might want to control this robot. and then if it finds commands trying to control the robot, it lets them actually control the robot. So
Yeah,
should we look at this Ackerman Drive node and see?
let's do it. Let's open up the graph there.
Open graph.
So this is what we call an omnigraph. It's just really nice because you have all of these different nodes that you kind of see on the left. And on the left, you kind of see all the list of different nodes and stuff. And these are helpful because they do various things. You can pick any one of them and see how it works with your workflow. And yeah, so the ROS bridge and Isaac Sim comes with this, as you see, this packages of nodes called Isaac ROS2.
Right here?
Yep. So if you open that up, these are all of the Omnigraph nodes that come with the ROS bridge inside of Isaac Sim. And they all do different things, as you can see. You know, we have stuff that subscribes to clock messages. We have publishers for clocks. We publish odometry, LiDARs, you know, anything, really. And so anyways, so for this case, let's just take a look at the
subscribers, right?
Yeah, there we go. All the subscribers there
and
that
look,
you would.
There's even an Ackerman Drive subscriber.
Yes.
I'm guessing that's what we're using.
That is what we're using. So here in this graph, it's set up to kind of show like a flow. So you know, initially we have one of the nodes. If you zoom out a little bit, Eric.
Oh, sure.
Yeah. So right here we can just start. You know how you see the on playback tick node. That is the one that's kind of controlling every other node there is. And there's other nodes that are kind of being controlled first, and then they control other nodes once the data that's processing whatever it needs to do is ready. Then it'll do an exec out and it'll control. So for example, let's just go through the Ackerman Drive steering one, right? So on playback tick will start the subscriber, and it'll tick that. So each frame, it will tick this subscribe node, and each frame it's now looking for messages from the network. And once it receives a message, it'll basically share that data to the Ackerman steering node that's right on the left, and then it has an exec out. So once you know that you have a message, it'll then take the Ackerman steering node. And then that one is connected to all of these different values that you see. So it takes those values as inputs like acceleration, speed, and steering. And then it has other values as well that are kind of filled into the property panel right here. So things like max wheel rotation, max wheel velocity, etc. And then once those are filled in, it uses all that data to then basically generate the left wheel angle, right wheel angle, and the wheel rotation that you need, or, you know, the velocities. And basically it's the same idea after that. It publishes all the data downstream and we go from there.
That's so cool. So let's try to use this. And we have a ROS2 ROS2 publisher that publishes the keyboard input, and we should be able to drive this. So let's give that a try. I've got to do this here, make sure it's always on stop. All right, here we go.
Gotta hit play first.
So we'll hit play. So now that's running. And if I run this teleop, so now we're running a ROS node that's publishing keyboard. So if I hit A, there you go. Oh dear. Oops. If I hit A, you can see that wheel turns. If I hit D, it turns. So if I hit W, oh shoot, it's not moving.
Oh.
It's okay. Let's debug this. So I'm gonna use Control C to stop the node.
Yep.
And I'm guessing there's some. Let's look at our nodes here.
The first thing I could see was, you know, we have a print node setup in one of the action graphs. So actually in this graph right here, it was printing out values for the wheel velocities. And what I could notice was that we're actually publishing non-zero numbers when you're hitting W. So that means we know for sure that the velocities are coming in.
That was there in the top left. I noticed that. It was like 0, but if I hit forward, it would say like 38 or something like that.
Right. So that confirms that, you know, the ROS part is at least working. The subscribers are working.
The steering's working.
The steering is working.
So I was guessing it's here in Ackerman Drive.
Well, Ackerman Drive we know was working just because of the values that were coming in. So, because as you can see, we have the wheel rotation velocity value in Ackermann steering that is then going to this 2-string node and then being published as text.
Well, let's look at the joint. Let's look at the joint, because sometimes in the past we've had it where the joints didn't have a drive on them, and so then ROS
okay, yeah,
couldn't control. That happened to us before.
That is likely.
Wheel. Let's just take a look at this wheel. Joint state. Oh, I don't have a.
I don't see an angular drive.
So let's select those 4 wheels. Wheel upright. Then it's going to be wheel knuckle. For the other 2, wheel knuckle. Go add physics angular drive. And let's see what happens now. So we hit play. And we come over to our console and run it again. Steering works.
There we go. Sweet.
Oh. There we go. Cool. It drives. Whoa. Cool. So everything's working again. Awesome. Well, that's so cool. It worked. I mean, that was simple.
Yeah.
So let's see. Let's reset it. And let's go to VS Code. Should we write the code that makes it drive itself now?
Let's do it.
Cool. No longer always on top for you. And I've got this. I've got
you
my
might want to
don't
zoom
worry.
in a little bit more.
Okay. Thanks for that. And then, I don't know how to do that in Linux.
I just do a Control plus. Yeah,
Control
there we go.
Like that? How's that text? Go one more. There we go.
Looks good.
All right. So first we have to initialize the AI model. And that's going to be, so if we just create, we're going to, and if you look at some of our previous sessions, we are going to create the model to match the model that we had in the extension, because we are going to run the same model that we trained before. So it should be almost exactly the same. So first we're going to grab the GPU. And here we say CUDA to make sure it's the GPU and not something else. Now we're going to create our model. And here, this is where we have, we're going to use that same policy. Oh, this code is wrong, I happen to know. I've renamed some things. There we go. So we initialize it. And if you remember, that policy is just saying what image transformers do we use when we train, and how many nodes in the neural network, and is it fully connected, and all that kind of stuff. And we want to use the same model with the same number of layers, or else obviously the evaluation wouldn't work right.
Yeah.
Now we want to make sure that model is on the GPU, not CPU. And then, so that's that. And then next, if you remember when we trained the model, we could train it, and then we had load and save buttons. Here, we're just going to go ahead and just load what we've got. Oh, sorry, just a second. And like I said, I'm using a cheat sheet, so don't think I'm like such a whiz programmer that I don't make any mistakes, right? That would be disingenuous. Cool. So we're just going to grab that. I think that's passing to the initializer is. Well, no, I'm not sure where that's going, but oh, I see. Yeah, that real path is just grabbing the path of kind of this module, if you will, of the Python file that's running. So then we just got this kind of hard coded here. Of course, that could be an input argument. Right? That could be a command line argument if you wanted. That wouldn't be a very hard change. So then we're just going to join those two paths to come up with our full path to the model.
And this works because the model file is in the same place as the Python file, right?
Yeah, that's right. So if we just open this up, you see my project here. You'll see here's model evaluate, and then right here next to it is road following model.pth.
Awesome.
Good. Let's see here. All right, and so then now that we have that, we look at our PyTorch model, and we are going to load the file. There you go. So now that's the full initialization code. Cool. So the next step is we're going to actually, so we've got this image callback, right? This is part of our subscriber. And we're looking for image messages that are sending out an image. We're looking for topics that are publishing images. And I think we're looking for a specific topic. Yeah. So you'll see here that we're going to look for a specific. Where do we register the topic? In here.
So that would be when you create the node, right there. Yeah.
Okay. Great. So this is looking for the RGB topic, and if the RGB publisher is publishing RGB messages, we'll receive them, and it will call whatever function we say here, right?
Yeah,
and
right there.
And it's looking for image messages, right? Isn't it message type?
That's right. Yeah.
It's looking for something with a pill.image in it. Cool. So this is going to get called whenever, and we're going to have a message. So looks like the message has got a width, a height, and probably the image itself, I would guess.
Yep. It should contain a data buffer.
So first we're going to go and take the model, and we're going to put it into evaluation mode instead of training mode. And then we're going to create a pill.image from the buffer, from that message we get in. It's an RGB image. It's this big. And here we go, message.data.2 bytes. So now that we've created an image, we've got to pre-process it. Uh-oh, wrong line. Cool. Okay, and here what we're going to do is this is saying it's a only grab the first three columns, right? Is that what that means?
Yes, I believe so.
And then grab all the rows. And we're going to put that image onto the GPU so that we can use it. I don't know what this. I honestly do not know what this one does. Why we had to do the. So when we process, get the image back, we're doing this. Is this to kind of reduce any outliers that we might get back, like from being too big, or?
Perhaps something like that. I'm also not entirely sure, but
Yeah.
it seems like we're creating some sort of average value
This is the
that we
standard
can then later
deviation.
use. Yeah.
Yeah. Michael Gustert, we had on a few weeks ago. He helped me write. He wrote this and let me shamelessly copy it. And I'm learning, but I've got some progress to make. That's for sure. But typically with these, it's very, this is all this data science stuff. It's got a lot of statistics with it and a lot of kind of data processing. And a big problem is that a lot of these models will produce really wild, like a wide range of values. And so my understanding is that we use these means and standard deviations to kind of tone things down a little bit so we don't get really huge outliers that mess things up. None. Actually, if I remember right, this code might actually be from Chitoku, who's another AI wizard. I'm so lucky that I get to work with these people like Jen and Ayush and Chitoku and Gus. I have so much fun, guys. All right. So now we're just kind of processing that image, right? It's like what we've done. Yeah, there we go. So look, if you look, we've got the mean and standard deviation, and we've taken our image that came in, and we've run it through this processing pipeline that tones things down a little bit. So it's more, it doesn't have any really bright pixels or really, I don't know, it just kind of processes it to a state that the model can understand a little better. Okay, so now we just call prediction equals self.model. Now we actually run that image through our model. And then, no, don't do that. I actually hit the power button. Oh dear, that would have been bad. Prediction X, prediction Y equals self.xy to row call. And here we're going to convert it to the coordinates of our viewport. Is that right? No, that's not true. It comes in this weird PyTorch data structure. And for some reason, when you just pass that to the function, it pulls the values out. And Ayush and I just didn't figure that one out yet. We should probably dig into that more, but just haven't had time.
We're just unpacking it. Yeah.
It just unpacks it to an X and a Y. And let's see. Okay, this is where it gets kind of fun. Well, for me at least, because we've got values coming back from our model at this point. And if we just pass we can't pass an X and Y into the steering of a car. So we get to use our creativity to interpret those values and say, okay, we get these values. What do we actually want? How do we want the car to steer, right? Here, just a second. Oh, great question here from AE Robotics. Let's just pause real quick. Okay, hi. Can we use Isaac Sim ROS 2 without installing NVIDIA Omniverse on a Jetson device? Jetson device is ARM64 architecture. So it's not, well, first of all, you do not have to install Omniverse on your Jetson. Definitely not. But you wouldn't exactly be using Isaac Sim ROS 2. So the way this works is you've got ROS 2 running on your workstation. You've got Isaac Sim on your workstation, and then you've got those ROS 2 bridge, Isaac ROS bridge graphs nodes that are publishing and subscribing information to your network, well, you'll need to write some nodes on your Jetson that publish and subscribe in the same way that your graph nodes do in Isaac Sim. Is that right, Ayush?
Yeah, so you can just create ROS2 nodes, and those are very lightweight. So you can just create those and put them anywhere you like. It could be on your Jetson device, and then you can just subscribe from the sim data via ROS, via the ROS topics, and if they're on the same network, then it should just work.
Yeah. So, great question. And first is tensor and other tensor. Yeah, and that's the world of data science, is lots and lots of converting this array to that array, and there's so much data processing and converting one kind of a thing to another kind of a thing to another kind of a thing. And my signal's coming in as an image buffer or as an image file. How do I get to an image file to the PIL format, and from there, how do I get it onto my Torch device? There is a lot of that I'm finding when it comes to working with these models.
Also, I do see on line 63, tensor is not capitalized, and maybe that's what they meant.
That could be it too. Yeah, there you go. That could be it too. Oh dear, who's driving this ship? All right. Yeah. Okay. So now let's actually. So what we're going to do here is we're going to take the forward vector, and we're going to take our XY coordinate we get, and we're going to go from the very bottom middle of the screen and draw a line to that one. We're going to take the dot product of those two vectors to calculate the angle between forward and whatever direction the car wants to steer. And we're saying that's our kind of our initial angle we're going to work with. And so forward vector is np.array 0 and then -1. And if you remember our screen space, the top is 0 and the bottom is -1. Or sorry, is 1. So we have to make sure our forward vector is actually kind of facing backwards. Offset. And what this is doing, this is a point in space, or a vector, from the origin to the bottom of our screen. And so then our trajectory, if you can just add vectors, so we'll just take that vector that points to the bottom of our screen and subtract that from the vector that goes from the origin to our prediction, and that will give us the vector from that bottom of the screen to the prediction. Let's see here. So that's our vector from the origin to the prediction. And then we subtract that offset. Now our trajectory is correct. And then, do we need math? I don't know. My cheat sheet is, I think, wrong here. I don't think we still need math to import math. We were playing with a few things here. Like I said, you're always converting between different formats using different libraries, and so there's a bit of fiddling around with that stuff. Okay, so we'll turn that trajectory into unit. We want to work with unit vectors. There we go. Got missing an equal sign there. So now we can do our dot product. Okay, now we get to a little bit of magic code here. Let me explain it. So this is our raw angle. It's just the angle between those two. But as we looked at it, it was just a little too dramatic with that car. And so first we divide that angle by 2. We also noticed it was always steering to the left. And so we're going to shift it back to the right by 15 degrees. And this is a little bit of, like I said, kind of some, I'm missing a parenthesis somewhere, but a little bit of magic code to, so, look, the model's not going to be perfect. And a big part of using a model is going to be, how do we process that output to make use of it? And in this case, we're getting, in general, when we evaluate, it's trying to steer more left. And if on the turns, and if it's on the straights, it's going to go more towards the center. And, it's roughly in the right region, but it's steering too far left. And also it's steering a little bit too dramatically. So what we're doing here is we're just kind of fixing that output, and so that it'll work. And yeah. So now that we have a steering angle, we're going to package that up and publish it. So I make a new message here, and let's fill it with its stuff. Message.header.stamp equals. This is that real time thing, right? We're adding a timestamp to this message. And we're adding that steering angle to the message. And here's the next part. This is some magic, right? If you notice, our model doesn't do anything to do with throttle, but we're confident that we could make the car drive a little faster if we do some stuff with the throttle. Actually, I'm going to go ahead and leave that. If you come to GTC, then we'll talk more there about how, and that'll be one of the challenges in the class, right? And
yeah,
and we'll talk a little bit about how, even though we're only getting steering out of this, the challenge here is, if you only have steering from your model, how could you come up with some advanced throttle control from just steering data? So we're just going to say message.drive speed. Let's just choose like a slow speed here. Let's do like 4. And then, so we're going to do that, and then we'll say self.publisher.publish message. And that's it. So that should work. I'm going to save it. And let's try running this. So now it's going to be a very similar process. Model evaluate start.py, but there we go. Okay,
and just before you run it, maybe we can just do a ROS2 topic list just to show everything that's being published from SIM.
ROS2 topic list. Good call.
Yeah, so there we have it.
Command, parameter events, RGB. Now you won't see our evaluator yet because we haven't started it, but Python 3 is called, what's it called?
Model evaluate, I believe.
Oh, shoot. I got an error. It doesn't like the relative paths from this one. Omniverse likes relative paths because it's actually running in an environment. If you're running a raw file, it's just going to look next to it. So you don't need it to be read. Well, it can be an absolute path, but from where the file is, and so it's just a little dot of a difference, but it's just an absolute path instead of a relative path. Oh, is it running?
Oh, it is. Right, of course. It's just Python.
What are we saying here? I'm gonna make this a little wider so it's easier to read. Didn't make a difference.
The speed field must be a float.
Oh, I know what it is.
I
I don't have
think
I
now
don't have a
it's
0.0. I put it
yeah.
4. It's picky. If you don't put a oh gosh, 0.0. There you go, Python. Give me a break.
Gotta love live streaming.
Okay, it's driving. Oh, come on, go to the right.
Uh-oh.
Oh dear. It's not steering right.
So this is a good example of what not to do when driving, right?
Oh, you know what's going on? Oh dear. Oh shoot. Watch my frames per second on this poor workstation. Oh dear. Oh no. I don't know if I can get it to go on this laptop. Because look at my frames per second.
Yeah.
It's I mean, even holding still, I'm at 60 frames per second. Let's see, how could we solve this? Let's try biasing the steering even more because it's steering too far to the right. And let's slow down the speed on it. Let's try that.
Yeah, let's do that.
We've got 10 minutes left. Oh dear. Let's hope we can get this to work. I'm just going to be straight with all of you. It's working on my where was it working? It was working on your workstation, Ayush.
Yeah, I can pull it up if we need.
Let's start pulling that up. His is going to be a little bit stuttery frame rate because he remotes into it from his home. So it's like, and then he's broadcasting on here. Oh, good question. So his question, FPS shouldn't matter for steering. You know what's going on, I think, is that it's so if the FPS of the view kind of the display drops too much, it will drop the calculations per second of the simulation. So if you watch the simulation, it's getting less and less accurate. So when the FPS drops, the simulation gets worse. So watch how much this car wobbles back. Like watch the suspension move, and as it turns. I don't know. I think it's just, yeah, it's just struggling here. It could be that the steering is something wrong with the steering.
It could also be the physics, perhaps, because it does look a little bit slow.
Yeah, so I think the physics is kind of not working right. But, well, okay, it's tuning. It's actually, it's more than that. If you recall, I'm on my, 3060 laptop here, which is barely meets the minimum requirements to run Omniverse, let alone run a really good physics simulation and run an AI model at the same time on the GPU. We are maxing this thing out. It's really, yeah, it's really struggling to keep up here. But it's the Linux workstation I've got. So let's go back and let's tone down the throttle to slow it down. And I'll make this like 30. Or make it like 20 to start with. And let's try again. Okay, there we go. Okay, it's getting some time to respond now. I saw that it's going straight at least. Now is it going to turn? Come on, buddy. It's not turning. I kind of wonder if something's wrong with our steering angle. Did I add the steering angle? Yeah, right here. Can I just like print the steering out? Let's go print steering
Sure.
angle.
Yeah.
I wonder if I have a. So what's going on here? Because it's not steering at all. Look at those tiny steering angles. See, they get bigger. Okay, so that is a problem. Let's review this code and see. Uh-oh, what was that mirror? All right, let's review this code. I've got an integer in here. I wonder if that's getting rounded. Let me see if I had that in my cheat sheet. No. Did you see that, Ayush?
No, I didn't.
This was just -1.
Oh,
so
no.
that was truncated, right?
Yeah.
So our forward vector was probably 0 or negative, or I don't even know what. So that's definitely a mistake. Let's try that now. Let's try that. Okay, it's running. Okay. I think I've got another bug in there. I mean, I think, let's take a look here. Let's delete that print. And let's, alrighty. So model is in evaluate mode. The image from buffer with height, message.data 2 bytes. Tensor image transforms.function to tensor image. Image is equal to tensor image, :3, .2, self.device. That's all looking good. Let's look at the mean and standard deviation. The mean torch.tensor 0.485, 0.456, 0.406. CUDA. Yeah. 229.224.225. CUDA. Looks good. Image sub mean : none dot. So subtract and then divided by standard deviation : none. All right. Image is equal to image none, dot. Looking good. Prediction equals self dot model image. So that's looking right. Prediction x, prediction y is equal to self dot xy to row call of dereference prediction dot squeeze dot CPU. Forward is np dot array 0 0 negative 1 0. Offset is equals np array 0 0 1 0. Trajectory is np dot array. Prediction x dot item, prediction y dot item, minus offset. Unit trajectory dot, np dot linear algebra dot normal trajectory unit forward. Oh. Steering angle, np dot arc cosine, np dot dot. Oh, look at that. Once again, pass an integer in. Wonder if that was it. Okay, it's running. Come on, buddy. Steer those wheels.
Yeah, I'm wondering if it's like a physics-oriented thing. Maybe it's not reacting fast enough.
Yeah, I think that there's, except that if I look at this, when I was printing out the angle, let's print out the prediction X and prediction Y, right? Print prediction. Print Y. Prediction X, prediction Y. Because those should be fairly large numbers. It should, because that's the range is like 1280 by 720. I don't really care. I'm just going to print the X because the Y isn't as important as the X for this. Let's just see if what we should see here is as we get closer to that corner, the X should get smaller, right? It should become more negative.
Are we going to end on a cliffhanger?
Not a total cliffhanger because I'm guessing Ayush has pulled his up, or have you pulled yours up, or so we can show it off?
I am checking to see.
Let's see. If not, we will end on a cliffhanger because I know I can get this working.
Do you want to just go through some of the questions in the chat? Finish up?
Let me just see this print one more time here. Okay, here's my X. It should get... I wonder if we're using the wrong model. So we're not getting anything out of this model. See that? The model is not steering. So let me do this real quick. Where is that one? Let's go through some. Yeah, we should go through some questions, huh? I think it's running the model, and so I'm not getting the model is not giving me predictions back that are turning left. So I think maybe we've got the wrong model in there, and I don't have time in 1 minute to fix that one.
Yeah.
So we'll come back to it. Maybe next week we can try again here, and I think we'll get it next week.
Hey, well, at least we have a video that we could show of something we had recorded earlier.
Yeah, would you show that video? And I'm going to start answering some questions while you pull that.
Sure thing. Yeah, let's do that. All
right. Are you guys also coming up with digital twin using ROS for mobile robots? Yeah, that's what this car is. This car is essentially a digital twin. You can drive it here in Isaac Sim, but it's built off of the suspension geometry of a Traxxas Slash. So it's a digital twin of a Traxxas Slash right now. And we've got an Onshape template we'll be sharing soon that you can take some other remote control 1/10 scale remote control car enter your dimensions, and it'll just kind of automatically get a digital twin of that car.
Hang on 1 second. Let me just pull up the video.
Yeah, that's an interesting. you can't. This isn't quite so. Add your Orin in parallel for a GPU boost. I have learned you can buy external GPUs for laptops. So that's one idea, is to give it another GPU, right? And then, well, this is cool. We've just, for the first time, we're streaming on the Omniverse X as an X live stream, and here's our first X comment. Thanks for streaming here. You're welcome. Thanks for watching. It's great. Is it totally Python based? Yeah, ROS is totally Python. I think that the ROS bridge you wrote in C++. Is that right?
Yeah, so it depends, but there's a lot of it that's Python. We did Python for simplicity, but it's obviously better to do C++ for performance. So
yeah.
it's both. That would be the answer.
And then, what articulation control mode are we using? Position or velocity control? We're using position control for the steering and velocity control for the throttle, for the drive.
Yep.
And the rest are just kind of trying to help us. There we go. Those are our questions. Do you have that video you can share?
Yeah, I have it. Are we sharing?
Let me. Here we go. There we go. Let it rip.
Yeah.
So we had it working on Ayush's workstation a few days ago, and here you can see it driving. And this is completely controlled. You can see what's that printing in the console? Is that the ROS output?
That would be the velocity, I believe, that it's getting.
Yeah. So I'm really bummed we didn't quite get there today, but really, I know it can work. It might be the simulation on my laptop because it's struggling, but I also am not seeing the numbers I would expect come out of that model, and so we will we'll get it figured out and show it off next week. We'll get it going. So, yeah, thanks. And then one last question. What is the Omniverse coder stack? That is Python or C++. And I just want to thank you all for joining. And cool session. We got the car driving with ROS with keyboard. So that was cool. We've got our ROS nodes publishing and subscribing correctly. Just not quite driving yet, is it? So that's all right. Next week.
We'll get him next time.
All right. Hey, have a good week, everyone.
All right. See you.